simple geometry, more practical, more everything together. So the first question says here, well, they give you a whole lot of information next to the sketch. Please make sure you read everything, because they might give you something that's not on the sketch. And they did. They told you that N was that coordinate pair, and P was that coordinate pair, and N was that coordinate pair. They told you that this was alpha and beta, and they actually also said to you that beta is an inclination, and alpha is an inclination. And then they said that theta is the obtuse angle formed by those two straight lines. Also, they said to me that AR has an equation, which I wrote over here, which you must also do. So when they give you any information, or you find out as you go along any information, put it on the sketch. Otherwise, you're going to not realize you have something that you have. That was the equation of the straight line. So they won't give it for nothing. Right, first question says, find k for me. You knew it was going to come when they said that there's a variable of k. They find k for me if they tell me that M and P and N are collinear. What does collinear mean? What do you use whenever I tell you the word collinear? Gradient. Excellent. Because if points are collinear, then the gradient between them stays the same. So you will normally go and then say gradient between M and P, P and N, and M and N are equal to each other, and if they are, they're collinear. But this time they tell me that they're collinear, so I've got to go find for K. So what am I going to use? Still? Gradient. So now find the gradient between, for instance, now this is the one I'm looking for, so I need M, and then I can go MP, or I can go MN, it doesn't matter. I'm going to work out the gradient of MP by saying, formula, and then if I take those 2 points, I've got 2 minus 0 over 0 minus K. But then I can't get an answer for that. That's the answer. But now I also know that the gradient between P and N, I'm going to actually get. And then I can put that equal to this answer. So that's how I'm going to get to the K with a little equation. So I'm going to say, but the gradient between P and N, now you don't have to repeat yourself, but you can. Between P and N is going to be y2 minus y1 is 4 minus 2 over 3 minus 0. And please remember, you can swap that around. But the 4 and the 3 go together, the 2 and the 0 go together. You can't have 2 and 3 together and 4 and 0 together. You can have the 2 in the front, but then the 0 is also going to be in the front. You with me on that method. So when I do that, I'm going to get 2 over 3. So what has that helped me? So that you know that 2 over minus k is the same as 2 over 3. For that, you're going to get the mark, knowing that that gradient and that gradient is the same because they sit on the same straight line. They're collinear, the gradient stays the same. Please make a deduction for me. K is negative 3. Excellent. Why, you haven't even done a sum, but can you see that you're making a deduction? It's 2 at the top. So minus k should be 3, so k should be. And you can do that. And you can even go cross multiplication, then simplification, and it still gets negative. But this is a nice example of showing you we don't always just have a logical deduction by exponential equations. This is also a logical deduction that we made over here. Second part of the question, they just say, find the angle theta. The moment that they say find an angle, that means I want it in degrees, right? Mm-hmm. The moment that you see it's degrees, it's got to be something to do with inclination. Is theta an inclination? No. But I will have to get it using inclination. But the only inclinations that I have are angles between the x-axis and the line. So that means that beta is an inclination of this red straight line. And alpha is an inclination of that purple straight line. And if I get them, how will I get to theta? By using a triangle. Do you see it? Because in general, I can actually give you that tip always to go and find a triangle somewhere. So this would be the triangle I'm looking at. If I find beta, which is an inclination, alpha, which is an inclination, how will I get to theta? Well, you can go straight line and some of the angles of a triangle, but that's geometry, right?
Yes.
That's why it's called analytical geometry. You're not going to do all that geometry in there, but there's certain things that you're going to use. And you're also not going to, like in geometry, all the time tell me some of the anterior angles or perpendicular for some reason or alternate angles. You just give me the answers because it's not geometry, it's analytical geometry. So tell me what the method is. You first of all got to go find alpha and beta. How do I find alpha? So please tell the marker. For alpha. Listen marker, this is what my process is. I'm going to find alpha now doing what? How will I find an angle, an inclination? If I have the gradient. Do I have the gradient for this line?
Yes.
Yes, you worked it out. You might have missed it and you're going to work it out again and say, oh, what a waste of time. But you've got it. You already know that the gradient of n was equal to 2/3. Please don't get confused with k and the gradient. The gradient was 2/3. So the gradient is 2/3, and that is why I can say that tan of that alpha is equal to 2/3, because the formula for inclination is tan alpha is equal to the gradient. Then I simply say shift tan, and the answer is? Say again?
33.693.
Thank you. And why don't I do the whole case? You know that it is actually a small little case. I'm finding the angle. You've got a positive value for tan. So it's actually going to be there and there. But then the logical stuff behind it comes in. Because now inclination can only be for a positive line between 0 and 90, an acute angle. For a negative line, negative gradient, an obtuse angle between 90 and 180. So practically, this makes no sense. It can only be in the first quadrant, and then it is only the reference angle, which I'm not even writing. So that's why alpha is 33, comma
6.
Let's look at beta. Oopsie, but I don't have any points.
But you have a gradient.
But I have the gradient. Given, I'm just going to read. You see it?
Yes.
And if you didn't put that line there, you might have missed it. The gradient is equal to -1/2. So for beta, I'm going to say, let's take the gradient of AR, which was -1/2, and go get the inclination. But critical, if it's degrees that I'm after, it has to be something to do with inclination. So this inclination, I don't even have to go work out the angle. The gradient, it's been given to me that it's -1/2. Another little key is sum. This time though, the angle is going to be obtuse between 90 and 180 because it's a negative gradient. And then I'll do the little summing for myself and say, well, tan is actually negative in those two quadrants. Doesn't make sense for now when I'm busy with inclination. When I'm back into case with normal solving general solution for trig, I'll do this again. For this practical stuff, it's unnecessary. So I'll do first, get my reference angle, which is?
26.5.
How much?
26.57.
Okay, because remember we always round off to 2 decimals and somebody says something else. And then I'll go for the second quadrant and say beta is 180 minus. So will this ever change? If tan is positive, it's just straightforward, the reference angle. If it's negative, you're always going to say 180 minus. Always, because I want to get you into little fixtures that you always know this is what you're going to do. So it's going to be 180 minus that amount, which is what? 153, 43. Now, because I've got beta. They never even asked me for beta and for alpha. They just asked me for theta. Now, guys, I only want the answer. Because I know you're going to do a few things good on the sketch. That answer there is 153,43, meaning that this is the 26,57, because they have to add up to 180. You see the logic behind it? Or if you just go again and subtract it from 180, you're going to get there anyway. And then some of the angles of a triangle. But please remember, it's shorter to do the following. Exterior angle of a triangle. Is it the exterior angle? Yes, because one of the sides have been extended. Exterior is equal to the sum of the opposite interior ones. So if I have the exterior and one of the interior ones, it's just that minus that will give me theta. How much is it, please? 1? 119.7. 4, thank you. And nobody knows how I got there. No, nobody cares. That you said straight line for some of the interior angles or exterior angle. I just need the answer. So that's why this will usually be like 2 marks and 2 marks and 1 mark, 5 or maybe just 4 marks for the whole system there. Getting to theta, but remember what I showed you now? Whenever you've got a set of whatever triangles there might be, maybe even there's another one over there, and I'm looking for angles, it's got to be something to do with inclination. The lines that I've got, this will be an inclination, this will be an inclination, this will be, and then I've got to move step by step by step to get to the one I'm looking for. Can you see a triangle?
Yes.
Can you see A, B, C? You see it?
Yes.
So I have to work out those two, not this one, unnecessary. I've got those two, I've got that same basic scenario going on. You see it happening?
Yes, ma'am.
Alright, but you've got to get used to that. Question 4.3 says, find me MR. What does MR mean? What does that mean?
The length.
A length. MR is a length, a distance. Distance formula? Maybe.
Yes.
But let's go find M and R. M was bad. K is -3. I should have written there long ago that K is -3. If I can only find out what R's x-intercept is, then I don't have to do distance formula like in the algebra when we did functions. If you know what it is, then you can just say what the length is. But what is R? How do I find R? R is the x-intercept of that straight line. But nobody's telling you, listen, go get that straight line's x-intercept and then find it. They're just finding MR. R is the x-intercept of the straight line. So to find the x-intercept of AR, you'll put 0 in the place of y, and then -1/2 x plus 4, making it x is equal to 8 times by 2 times by 2, right? So if x is 8, where am I now on my graph? That means that this is by 8. What's the distance? Not 8 minus 3. Distance 3. Distance 8. So MR is 11 units if you want to. Please? 8 units. 3 units, not -3. Distance 3. Distance 8. Total distance of 11. Are you with me?
Yes, ma'am.
Okay, last question, and they love asking this in analytical geometry. Find me the area of a triangle. Who can still remember what the area of a triangle is? I'm so happy. All base times perpendicular height, and very soon in the next term, you're going to learn something else for area of a triangle, which can be used sometimes in analytical. Sometimes kids do weird and wonderful things that take them a broad way around that they actually shouldn't have done or could have saved some time on. But if it's right mathematically. So you're going to get something else to do with area of a triangle. But for now, half base times height has been what you do since grade 7, 6, whatever. So what is the base and where am I? M in R, let's make it red. M in R. There's M. There's M. It hasn't been even joined. So if I go there, triangle, what is the base?
Isn't the x are 11 units?
What is the base?
With 11 units.
The 11. That's what they do. They scaffold they build upon each other. So that's why they wanted you to get MR. Because now you know that MR is 11 and that's your base. Are you seeing it? 11. But where's the height? 4. Oh, you're so clever.
Oh.
Because there's the top, going perpendicularly downwards with a y value of 4. So the y value there is 4 and your answer is 22 what? Area? Units squared. And some people write units square like that or square units or whatever, and that's not even necessary, but I'd like you to be sharp on that. Okay, then there's one other one that I have to mark with you.